Okay, hello everyone. I've got the top of the hour on my clock, so we are going to get started. We've got a lot to get through today, but I do want to say thank you for joining me. I hope you're all having a good day. And so the focus of our presentation today is going to be on using the GeoWeb 3D confinement system for dams, dikes, levees, and spillways. So I'm your host, Sam Justice, and I'm a licensed professional engineer in the state of Wisconsin. And I have degrees in civil and geotechnical engineering. So I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products. All of our products are made in the upper Midwest of the United States in Wisconsin. And we do have an extensive national and international distribution network. And then we also offer technical and site support, as well as a free project design evaluation from our in-house design engineering team, part of what I'm with. So some learning objectives for today. We're going to learn about how the GeoWeb system can protect against erosion from water flow in a variety of project conditions, how the GeoWeb GeoCell system can accommodate typical construction issues and design challenges, and then also how the GeoWeb system can reduce the vertical pressure on subgrades to allow for a reduced cross-section in load support applications. So first, a little bit of background on Presto Geosystems if you're not familiar with who we are. So we worked with the U.S. Army Corps of Engineers to develop the GeoCell technology in the late 1970s and have been innovating in this market ever since. Our products have been used in over 200 countries and in every state in the U.S. We go beyond simply providing a product. We're here to help you and provide a complete stabilizing solution. And so, like I mentioned, we do operate in 3 product areas. So the first is soil stabilization using our GeoWeb GeoCells. And you can use those for load support, where you've got vehicle traffic, slope and channel protection, and then also in green retaining walls. Then another product area is going to be porous pavements, which we have both a vegetated and a gravel solution. And then finally, we have lightweight, reusable construction mats. So today we're going to focus on the GeoWeb system, really focusing on slope and hydraulic performance, and then also a little bit of load support applications. Okay, so now we're going to cover a little bit of general information about the GeoWeb system for those that might not be familiar with this type of product. Like I said, we've been around for about 40-ish years, but you still might not know who we are and what we're doing. So I'm going to teach you a little bit today. So the GeoWeb system consists of 2 main attributes. The first is going to be the cell or the container size. So the cells come in 3 diameters, a small, medium, and large, and then heights of 3, 4, 6, 8, and 12 inches. So 5 different depths to choose from. So the cell aperture, or the opening, and the height are going to be selected following an evaluation of project-specific needs and site conditions. That's something that myself and our in-house engineering team can help you determine. So another thing to point out is going to be the ultrasonically welded seam, and that's going to be where all of these connecting points are. And so this is going to be really important to the function of a GeoCell. So the stronger the seam strength, the better the performance of the GeoCell. And GeoWeb is our proprietary version of the GeoCell technology. So a strong seam allows for heavier infill materials, steeper and taller slopes, and better overall lifetime performance. The GeoWeb is produced using high-quality virgin high-density polyethylene, HDPE. And so that's a plastic that has consistently strong welds at all of these cell junctions, but it also maintains semi-rigid ductile properties within the cell walls. Also has high stress crack resistance and overall toughness and long-term durability in the environment. So our GeoCells don't use anything, any fillers or any exotic polymer alloy blends, anything like that. It's just pure HDPE. And we do that because if you do add fillers, it can ultimately reduce the weld strength and the environmental stress crack resistance. And it's really not what you want. You don't want those sorts of failures to come in. And there are competing GeoCell products out there that do that. And so we just want to let you know that having that pure HDPE is really going to be the best way to avoid weld failures and the damaging effects of differential settlement. You want unity in your performance and your function across all elements of a GeoCell system, which is going to be much more important than focusing on a single property alone. You want that uniform system. So I'm going to keep saying that, uniform. And it's really not important if you remember every single one of these properties of the HDPE plastic or anything like that. Always happy to talk about it if you do have questions, but it's really just the important thing that we want to have sort of stick in your mind is that uniform performance, not focusing too heavily on one aspect or another. You want everything to be cohesive and uniform. Okay, so I said there were two main attributes for the GeoWeb system. The second is going to be the infill material. So it's going to be what you put into the container. And so it's an important benefit of using the GeoWeb system is that you can use a low quality aggregate, sand, or even salvaged materials to infill the cells. So if you have something like recycled concrete or asphalt on your site, you can use those rather than an expensive engineered stone. And so using those salvaged materials can save a significant amount of money on the material itself, but also hauling costs if you have it already on site. And we can have the elimination of fines when it's desired, since the GeoWeb cells themselves provide confinement and aid in compaction of cohesionless soils. So that's another thing where you can have, less than perfect material and still have it be a good choice for the infill for the GeoWeb system. If you do eliminate the fines within your stone, you can improve the drainage and actually let the water flow freely through the system, preventing poor pressure buildup and global failure of the cross-section if that's something that you're interested in. And the ability to use sands and these low-quality aggregates really sets the 3D GeoWeb system apart from things like planar geogrids or geotextiles. So those products do typically require high quality materials with high friction angles to achieve their optimal performance. But with the GeoWeb system, low friction angle materials are going to be just fine. And the GeoWeb panels can achieve their full potential even with those poor materials. So it can be good cost savings in that respect. Okay, so in order for the GeoCell system to perform uniformly, I'm going to keep saying that word, it's going to be critical that both the factory welded junctions, so those are going to be those internal junctions, the seams that I talked about, then also the field joined junctions that connect individual panels. That's sort of a mechanical junction. And so you want both of those to perform at the same level that's going to be with the cell walls. So everything is as strong as everything around it. Again, uniform. So the three primary elements of any GeoCell system are going to be the cell walls, the internal junctions, and the connectors. That's going to be those mechanical junctions. And so they all perform uniformly as a complete system. Therefore, an incremental improvement in a single characteristic, such as the cell wall strength, is only valuable if that same improvement is made to all of the other components of the system. And the GeoWeb system is, as I said, manufactured with that high quality HDPE, where it's not focusing on a single property, it's focusing on being uniform across all of its properties. And so we've been doing this for over 40 years. And it has really stood the test of time. We are a leader in this industry. We haven't seen, failures of our system because of poor material quality. And so for typical sites, the GeoWeb system will retain its durability for greater than 50 years, which is typically more than sufficient for most project lifetimes. And so we really stand behind our numbers and our product so that you can deliver certainty in your solution as you build with all of these materials that you can trust. Okay, so with that little bit of a spiel out of the way, another thing about our complete system solution are going to be all of the extra system components that are the supporting pieces. And so these, again, ensure that uniform performance of an interconnected system, and again, protecting against things like deformation or differential settlement or any of those expected or anticipated failure modes. Having these components are going to help prevent that. So the first one, if we think back a few slides where I said, the panels come in discrete sections. And the average size of a panel is going to be around 250 square feet. It can be a little bigger, can be a little smaller, but that's about your average size. But really, your project is probably going to be bigger than 200 square feet. So you're going to need multiple panels to cover the whole section. So the ATRA key is our mechanical junction. So it's going to be one of those components that I talked about. And it's going to connect each individual panel of the GeoWeb into a single web that covers your entire section, or excuse me, your entire project site. So it allows for faster installation of the GeoWeb system, and it is going to last the lifetime of that project. So you're not going to see failure at those mechanical junctions. Those ATRA keys are going to last as long as you need them to. And so the specific engineering values of this ATRA key will ensure that the system is going to hold up to all of the anticipated loads over time, and it's not going to corrode like you would see with metal staples, and it's going to have the strength that you wouldn't typically see with something like a cable tie system. So next is to look at some anchorage options. So if the GeoWeb panels are laid basically flat on a flat ground, anchorage is not really going to be needed because it's just going to hold itself in place with gravity. However, if you start putting it on a slope and that angle starts increasing, the driving force of that infill material exceeds the frictional resisting force, and you're going to have the potential for sliding. So we want to do some sort of anchorage system to prevent that. So for some really shallow slopes, and typically for us, shallow means less than a 2-to-1, so less than about 25 degrees. And with that, you could do stakes. You can either do them, a standard metal rebar, or we do have one made with HDPE. That's what's shown on the screen here. And that HDPE is really good if you are in perhaps a saline environment, like along the coast. You're not going to have that corrosion that you would with metal stakes. So you would do the stakes, and the number of stakes is going to be project dependent. And that's, again, something our engineering team can help you determine. So if you do have a steeper slope, so if you're steeper than 2-to-1, or if perhaps you're in a very erodible soil, if you have like a really weak shale, or if you are working on a site that can't be punctured, say you have a geomembrane liner underneath a pond and you don't want to puncture that with stakes, there's another option for anchorage, and that's to use a tendon system. And again, we have a specific clip. It's called the ATRA tendon clip. And that's going to help transfer the load from the infill material to the panels, to the tendons, to your crest anchorage at the top. And so really only this ATRA tendon clip, this item that you see here, is going to be specifically designed to fully transfer safely and securely all of the forces that are placed on a geocell when it's on a steep slope. And so, like I said, all of our accessories and all of our different features have been designed and tested specifically to work together so that we can go from problem to design to construction solution with a single system that's going to work for many different application types. Okay, so with all of that sort of background about what the GeoCell GeoWeb GeoCell system is, we can look at some applications specific to things like armoring dams or dikes or levees with the GeoWeb system. So a typical earthen dam or dike application might look like something that you see here. So on the wet side, we could have the GeoWeb armoring, and that's typically going to have an aggregate or even concrete infill. And which one you would choose is going to be a little project dependent. It's going to be depending on things like your wave action, drawdown rates, anything like that you have. There's a lot of forces acting on, the upstream side of a dike or a dam. So all of those things are going to sort of help you decide what infill material is going to be most appropriate. But then we typically do also recommend that the GeoWeb panels extend from the wet side up over the crest and then down on the dry side. And so this would provide, a stable driving surface along the crest, so you can bring in maintenance vehicles or inspection access roads, anything like that. Typically, we would do an aggregate solution on that crest, so you'd have a gravel surface road, a little bit easier in terms of maintenance that way. And then on the dry side, you can either continue that aggregate if you want, a riprap surface, or you could even transition to a topsoil, grass vegetation solution for some of those natural aesthetics, make it look a little bit nicer, but you're still providing that erosion protection should your dam overtop. And that's why we sort of recommend the GeoWeb panels be on both sides of your structure. So I mentioned that the GeoWeb system could be used to stabilize the crest of dams or levees to create that drivable surface. And so that's going to be what we consider a load support application. So let's go into a little bit more depth about how that would work. So the GeoWeb 3D system works like this for load support applications. When a vertical load is applied, the active earth pressures in the loaded cell, which is going to be the one in the center here, pushes back against the passive earth pressures in all of the adjacent cells to form that stable system. Each cell helps support the ones around it. And the GeoWeb cell walls also transfer hoop stress. And that's going to be really important in keeping the system intact and creates what we call the mattress effect. So the strength of those seams, which we talked about in the beginning, those ultrasonically welded seams, and the material properties of the actual GeoWeb panels themselves, and then also that connection method. So that's going to be that Attra key that I talked about. So all three of those things are all going to be those important factors in determining how the GeoWeb system can improve the load bearing capacity. And so strong seams, semi-ductile resin properties, and integrated connections are going to be critical to that well-performing uniform system. So the GeoWeb system and its accessories are specifically designed to work together to create that effective solution. And it's really helpful in these environments where you have the potential for water overtopping. Potentially you have a bit of a soft soil environment, that sort of thing. And so you can see here the stresses on the subgrade for the unsupported subgrade on the left and the GeoWeb reinforced subgrade on the right. And notice how there's a complete elimination of those the highest stresses with the GeoWeb system. So that red and orange section completely gone. And the stresses are going to be distributed over a wider area. And so that's what we call the mattress effect. And so the mattress effect really reduces the stress that's reaching the subgrade and leads to a significant decrease in the deflection and rutting that's caused by continual vehicle tires. So it's creating a system where you're not going to get ruts and you're not going to have sunken drive lanes. You're going to have a sort of a floating mattress with the GeoWeb system holding everything in place, supporting your vehicle loads. And so for this one, the top schematic is, again, that unconfined aggregate. And you can see how it moves both down and out to the sides. to create those ruts. And so that's going to be a lot of maintenance that you have to do. Come in, fill those ruts back in, and try and make it be a drivable surface. So we're also not utilizing the full strength of the aggregate when it moves like that, because it's just getting pushed to the side rather than actually supporting the vehicle loads. And so that's why you'd want to use the GeoWeb solution. So it's going to help hold that aggregate in place so it can't move, it's not going to rut, but then also allows the full strength of that aggregate to be able to support the loads, so you can have a potentially thinner cross section while still supporting higher loads. So basically, the purpose of the GeoWeb cellular confinement system is really simple. It's going to be to stabilize the movement of unstable soils, both horizontally and vertically. And so the weaker your subgrade conditions, the more practical it is to insert the GeoWeb system into the design. It is an engineered system that's going to have, potentially a couple different types of geosynthetics, but it's going to be the best method of confinement and subgrade stress reduction in the industry. So if that's the sort of thing that you're looking for, you want to have less stress on your subgrade, you want to have thinner cross sections, that sort of thing, GeoWeb is the way to go. And we are always happy to, talk about how it works, talk about those sorts of specifics, but then also determine what is going to be most appropriate for, your individual project. Okay, so that was about the GeoWeb system for those load support applications. So again, those essentially flat areas, areas where you're going to have potential vehicle traffic. But the GeoWeb system, as I mentioned, also works as an erosion control system on your slopes, including some very steep slopes and in areas with water flow or wave action. So the GeoWeb system is an economical alternative to things like large riprap stone and things like reinforced concrete for dam faces or spillways. And like I said, it can even allow for that vegetated face that would otherwise just not be possible when you have potential water flow. That water flow could cause scour, cause rills, bellies, just rip up that vegetation. Wouldn't do that with the GeoWeb system. And so if rock is used as your infill material, you can have greatly reduced rock size. So going from something like 12 to 14 inch riprap stones down to something with a D50 of 2 inches. So pretty big reduction. And if you were to use concrete, you can actually cut out all of the internal reinforcement. You wouldn't need any sort of reinforcement bars because you would actually be having the GeoWeb panels as the reinforcement. So you can have a reduction in the concrete depth and elimination of internal rebar, that sort of thing. When using the GeoWeb for slope protection, which could be things like reinforced dams or levee faces over the top of dikes like we saw earlier, this is the type of cross-section that you might see. And these are some of the things that we had talked about. So there's the stake anchors if you have a very shallow slope. There's also the tendon system if you have a steeper slope or if you have a membrane underneath. And the thing that I kind of want to point out is on the right-hand side, it's labeled as the dead man anchor. And so this is really just one option, but you are going to need some sort of crest anchorage if you have a tendon system. You're going to need to tie those tendons to something at the crest of the slope to hold them in place. So this could be a dead man pipe buried in an anchor trench. It could also be something like an earth or a rock anchor, or you could even bury the GeoWeb underneath, a concrete structure. If you know that you have, a heavy concrete structure that's there, you could attach it to it or bury it underneath and let the gravity weight of that structure hold the panels in place. So a couple different options. So we can try and find something that's going to be, most appropriate for your specific site. So the GeoWeb system works in multiple ways to protect your slope surface, and it prevents significant movement of your soil or your rock by confining it within those GeoWeb cells, each one of those individual cells. And so it's going to resist things like mass movement, where it takes, a large section of soil and mobilizes it, down the slope. Slumping, which obviously you want to avoid. So that's kind of the biggest thing, is holding everything in place while still allowing for water flow over the top of it. And so it is important to note that the proper installation of the GeoWeb system includes embedding the GeoWeb panels into the crest of the slope, where I mentioned in that diagram there's that deadman anchor. And so by doing this, you're preventing water from flowing beneath the GeoWeb panels and undermining the system. And so the system does provide a way to either fully vegetate a slope, or you could even have stone or that concrete on the slope as well. With the GeoWeb vegetation option, like I said, that topsoil is confined within the cells, and then it actually grows your grass or small flowering vegetation, so that you don't see the GeoWeb plastic. You just see the nice green lawn, while still being able to withstand things like high velocities, high shear stresses from something like an overtopping dam. And this is a really low maintenance solution. You can either just let everything grow, let it grow wild, or if you do want to mow it, a standard lawnmower or any of your standard lawn maintenance equipment is going to be fine. The blade is not going to tear up the GeoWeb system or anything like that. So as long as the slope is shallow enough that you can ride a tractor or a mower over it, you can mow this just fine. No special requirements needed. But you can also do what we consider hard armoring solutions. So that's going to be that stone or that concrete infill. This is even less maintenance. You're not going to have to do any mowing or anything. The stone is going to stay in place within those cells, so you're not going to have to come back and constantly be replacing stone or anything. And then concrete is, concrete. It's going to stay there, not going anywhere. So this is another potential option if you want even less maintenance, or if you have some concerns about growing any sort of vegetation. Perhaps you're in a more arid environment, that sort of thing. One thing that I do want to point out, and it's one of the best things about the GeoWeb system, and that's how much trust we have in the system working. And that's because we have the experience and the research to back up what we're saying. So we did a huge series of tests at Colorado State University in Fort Collins under the direction of Dr. Chris Thornton, who is a leading expert in hydraulic forces and the prevention of failure due to hydraulic forces. And so CSU is considered one of the top hydraulic research facilities in the world. And so we were able to work with both their indoor and outdoor testing flumes to do a huge number of tests with the GeoWeb system. And so first was with a vegetated system. And so that was performed with sort of two objectives in mind. And the first was the ability to withstand high velocities and shear stresses, which are going to be the main components you're going to think about when withstanding water flow. And the second objective was to compare the performance of the topsoil-filled GeoWeb system versus something like riprap or other conventional solutions like an erosion control blanket. And so the testing consisted of the 6-inch deep GeoWeb panels filled with topsoil, which is probably one of our more common recommendations for this type of project. And then obviously vegetation was allowed to grow to replicate typical field conditions. So a total of 10 tests with water flows lasting up to 1 hour were performed with varying conditions for flow rate, bed angle, bed slope angle, that sort of thing. And so the tests were done to see whether you would lose the grass blades, because obviously you don't want to just have all your grass get washed away and be a mud pit. And then was also done for how much if any soil was ripped out of the geocell. So sort of two different parameters there. And so the vegetated channels actually hold up really well against even turbulent flows, such as around corners or near rough terrain. So most people would think that a vegetated channel actually can't handle high water flows, but when it's properly confined within the geoeb system, velocities of near 30 feet per second and shear stresses of 16 pounds per square foot can be achieved, which is pretty good. And so you can see some of the results of the tests here. And so there's obviously lots of different types of grasses. I'm not, a botanist or anything, but I imagine choosing, some of the hardier varieties will improve these results. So, maybe talk to, a nursery local to you to figure out what's going to be best for your area. But any sort of grass or flowering vegetation is typically what we recommend. And then this is just sort of a quick comparison to show some really impressive results. So you can see the geoeb filled with topsoil can handle that velocity of around 29 feet per second. And that's compared to 12-inch riprap stones, which is actually closer to 14 feet per second, so a lot less. And then it also outperforms things like turf reinforcement mats alone, and doubles the acceptable velocity and shear stresses compared to things, like bare soil or anything like that. So basically the key takeaway from all of this is that the geoeb system provides twice the protection of 12-inch riprap stones, and is going to be a better solution than like a geotextile blanket or anything like that. There we go. So we also did testing with gravel or aggregate infill. And so the main objective here was to determine how much the geoeb system can aid in reducing the riprap size. So we want to go from those 12-inch stones to something a lot smaller. So again, lots of different tests, varying bed conditions, all of that sort of thing. And so did this testing both indoors and outdoors, and looked to see how well the aggregates stayed in place during the tests. So we wanted to see what would be the conditions that would prevent washout of the stone so that you wouldn't have to come back in and replace the stone, what's going to be there consistently. And so again, we got some pretty impressive results. So it can handle max velocities of up to 18 feet per second. So if we remember, vegetation could actually handle closer to 30 feet per second. So it actually handles some higher flows and shear stresses, which may seem counterintuitive, but then you kind of need to think about it as, what's the strength of this properly rooted large grass system compared to a single piece of aggregate? Because that's sort of the comparison that you're making. And really the important thing and the objective was to determine the reduction in riprap size due to the geoeb confinement. And also something to keep in mind, vegetated channels can really only withstand water on an intermittent basis. Otherwise, you're just going to drown your grass and it'll die. So if you do have continuous flow, so if you're on the upstream side of a dike, something like aggregate is going to be more appropriate. And so Dr. Thornton put together a design tool for us based on a rather complicated regression analysis, but it helps compare the reduction in the crushed aggregate confined within the geoeb system to conventional riprap. So you can see what the difference is going to be. So what it comes down to is that we can recommend the appropriate geoeb cell depth and rock size for a specific project so that you can be confident that the aggregate is not going to get washed away. And so it compares our solution to the U.S. Army Corps of Engineers design, and then also the ABT and Johnson design. So two different fairly common methods for sizing riprap. So this is a good potential reduction for using the geoeb system. And then finally, concrete is an infill solution. And so this is one where we actually maxed out the flume. So they couldn't pour any more water down it without completely overtopping the system. So it maxed out for testing at 36 feet per second. But there was no degradation of the concrete, no degradation of the soil underneath the concrete. So basically it's saying that this is going to be an excellent system for protecting your dam faces against erosion. And really that max velocity is probably going to be a lot higher. It's just not able to be tested that high. And so the GeoWeb solution was actually the only geosynthetic solution that actually maxed out the flume at CSU, and that's comparing things like turf reinforcement mats, large riprap stones, even articulated concrete blocks, things like that. So we are very confident that the concrete filled GeoWeb would work for even the most challenging of projects. Okay, so last little thing that we're going to do here, we're going to go through some case studies. Everybody likes seeing pictures, likes knowing that these things are out in the real world and they're actually working. So our first project is going to be the Mud Lake Dam in Gardnerville, Nevada. So this was a 100-year-old earthen dam, and it no longer met safety standards. And the owner was looking for a cost-effective alternative to traditionally reinforced concrete. So they ended up choosing the GeoWeb system. And part of that was because they needed a sandwich of a non-woven geotextile, a impervious geomembrane liner, and then another non-woven geotextile. So they had this sort of geosynthetic sandwich that they had to have placed on the dam face that they obviously couldn't puncture. It couldn't be exposed to the elements that could potentially damage it over time, all of that stuff. So they ended up choosing the GeoWeb system to be placed over this sandwich and ended up filling it in with concrete and then anchoring it with the tendon solution so that stakes weren't necessary. There was no threat of a puncture. And so you can sort of see the sandwich being built here of that geomembrane liner and the non-woven geotextile on top of it. So that tendon and Atra tendon clip, which is our little load transfer device that I talked about, was the anchorage solution. And one of the cool things about it is that you can actually assemble all of this with the GeoWeb panel and the tendon and all of the clips off-site, so you don't have to do it on the slope. You can do it, on a nice staging area like this. And it really minimizes the amount of time that the contractor has to spend on the slope. So that's going to increase your speed. It's going to be a lot safer. It's just going to make things a lot easier to be able to sort of pre-assemble everything like this. And then, so you can see everything has been placed on the slope and they're starting to pour their concrete here. And so you can actually sort of pour the concrete sort of just at the crest, and then you can see these guys not wearing fall protection, which is not a good thing. But you can see them coming in and they're raking the concrete down from the crest into the GeoWeb cells all the way down to the bottom, and then screeding to the top and making a nice smooth surface. So you don't have to bring in a tremie or one of those elephant trunks or anything to try and pour the concrete into each individual cell. You can sort of have it as a mass at the top of the slope and then bring it down to the toe. That's easier. So there's a couple different options for installation, and if you do have questions about that sort of thing, it's something that we can help with. So you can see a good mid-installation photo here, nice vista in the background. But the GeoWeb alternative cost was around $12 a square foot installed. Don't hold me to that price, but that's a good starting point to sort of think about the GeoWeb system and how it might compare to some other alternative solutions. And so it can be a pretty huge cost savings. When you compare to a thicker reinforced concrete section. So just something to sort of keep in mind. So another project was the Lake Hefner Dam, and this was out in Oklahoma. And so the GeoWeb system was just put on the dry side of the dam because they wanted a vegetated solution. But they also needed something that was going to hold in place so that they didn't have this continual failing of the roadway next to the slope. You can see it just constantly gets undermined and breaks, and they have to come back and patch it, and that's never as good. And so part of this was to also protect against overtopping from the dam, which would flow over the road and then down the vegetated slope. And so, they had this large riprap on the wet side of the dam, but pretty heavy wave action in this area due to high winds, which came in quite frequently. So they knew that it was going to be a rather frequent potential for overtopping, and they wanted to have something that would sort of hold up against that. So the lakeside was protected with just riprap. They chose not to use GeoWeb on this side. They just put it on the dry side. So you can see that coming in here. And the GeoWeb was actually put right up against the edge of the road pavement to really try and minimize any potential for, a scour area. So by putting the GeoWeb right up against the pavement, the overtopping water flow can come horizontally across the pavement and then right on to the GeoWeb system, which is going to prevent that erosion, prevent scour, help hold the road in place a little bit better. And they chose to use the Atras stakes for this slope. This was a 2-to-1 slope, so they were able to use stakes, able to go in pretty quickly. I don't know how well you can see it, but you can see the top edge of the stakes holding it in place if you look really closely in that photo. But so they were able to put that there, and those stakes are going to hold the panels and the soil in place to prevent sliding or slumping of the soil. And then here you can see this was about a year later, so time for that grass to really grow in and fully vegetate. But you don't see the plastic anymore. You don't have to worry about people seeing that and thinking that there's trash out on the slope or anything like that. It's just a good green slope. Like I said, you can mow this. Your standard lawn mowing equipment is going to be sufficient. You don't need anything special. You don't need to take any special precautions, anything like that. And then one last quick one was a impoundment pond down in Florida. They actually wanted to create a roadway system through the middle of the pond. And they wanted that for maintenance activities, that sort of thing. And so they actually wanted this as a concrete road straight through the middle of their pond. So they piled up and made an earthen dike and then put the GeoWeb panels on both sides and across the top of the dike. So it was wet on both sides and then smooth surface on the top. And so they were able to pour the concrete, you screed it flush to the top, make a nice smooth surface, and then let it pour down on the sides. And now you have a good, in place maintenance access road. You're not going to have to come back and keep rebuilding that earthen dike every time you drive on it. It's going to be able to support heavier vehicle loads because you do have that good concrete surface now. So just an interesting little application building through this sort of impoundment area. So if you have any questions about how that works, feel free to reach out. And then our last little area is going to be along spillways, so areas that are going to have potential, high water flows coming down through them. So this was one, again, in Florida, and so this was going to be the detention pond on a large medical campus. And so they wanted to have protection along their spillway and on some of their side slopes. So when heavy waters came through, they would be able to support that, bring it into the pond without, erosion or potentially, having some sort of side slope failure within their pond. And so this was a fairly small application just in this sort of flume area and along the side slopes. But this is a great way to show the versatility and the flexibility of the GeoWeb panels, because they can fit in this, sort of non-standard area and sort of flex around and make the shape that you need it to without doing a lot of site prep or site work. So this was another application. This was up in Pennsylvania. So this was another sort of detention stormwater management channel where they were going to be able to bring in high water flows during storm events and direct that offsite to where it needed to go. And so one of the things I'd mentioned earlier was that you don't need internal reinforcement for the GeoWeb system. You also don't need formwork for the concrete. The GeoWeb system is its own form and its own reinforcement. So you can really just lay the GeoWeb panels out how they're how they're needed in whatever shape you need. And then you don't need additional formwork around it. You just start pouring the concrete directly into those panels. So that really can save a lot of time in installation and all of that. Makes it a little easier that you don't need to be confined to rigid formwork or rigid internal reinforcement. You've got flexibility. You can make it look a little more natural, go around curves a little nicer, that sort of thing. And again, you can have the potential to reduce the cross-section depth of the concrete because it's confined within the GeoWeb panels. You can go as low as that 3-inch panel that you typically couldn't do with a reinforced concrete if you were to have rebar in there, because you need a certain amount of depth on either side of the rebar that you don't need when you're using the GeoWeb system. So it's another way to help reduce the amount of concrete that would be necessary. Okay, so that's the presentation. So basically, in summary, the GeoWeb system can be used for a wide variety of applications for dams, levees, spillway structures, that sort of thing. And it can offer both load support applications for vehicle traffic and erosion protection against water flow and wave action. You can have a variety of different infill materials, and you can even vary those within the same project, so you don't need to be limited to just concrete or just stone. And so it's going to be the best solution for your project. And we do offer that complete system solution, including our specifically designed accessories to ensure the longevity of your project with minimal maintenance requirements. And so part of our complete system solution is our technical assistance. So we provide free project design evaluations. So it's a form that is available on our website. You can just fill it out with as much information as you have. You can attach things like geotechnical reports or plan sets, things like that. And then it gets sent to myself and the rest of the engineering team here at Presto. And then we provide our complete design recommendation. So it's going to be any anchorage requirements if you need them, geotextile recommendations, help you determine what size and what depth of the GeoWeb system is needed. So small, medium, and large, and how deep that depth is, that sort of thing. And so we are happy to do any number of iterations of these recommendations to get you the best design for your site. And we deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specifications, so you can deliver certainty and build with materials that you can trust. No disclaimers, no concerning fine print. We stand behind our numbers. We have the research to back it up. This is something that we know will work for you. And that's it. So I do want to say thank you, everyone, for attending. I know that this was first day back for a number of people after a holiday weekend, so I hope this helped ease you into your week a little bit. Some housekeeping before we get to questions. You have earned a PDH credit for listening to the webinar. So we're making it easier and faster for you to obtain that PDH certificate. and that's going to be with our webinar dashboard. And the dashboard allows you to view our entire library of webinars. This is just one of dozens that we have. So if you have questions about other applications of any of our products, feel free to go into the dashboard and see if we have any other webinars for that sort of thing. But then it also allows you to download your PDH certificates for any of the on-demand webinars that you complete. And it will help, show which ones you've watched, what PDH certificates you have, that sort of thing. So in 2 to 3 days, by the end of the week, you're going to receive an email from Presto Geosystems with information on how to access that webinar dashboard. So look for that from Presto Geosystems. If you attended live today, you're going to automatically receive your PDH certificate from GoToWebinar, not from Presto Geosystems, but from GoToWebinar. And they will have a link for how you can download your certificate. And so you should see that usually within 24 hours. So if you don't see it, check your spam folder or see if it got caught up in any sort of email quarantine that your company may have. So there are a number of questions. I'm going to answer those, and the questions are all going to be recorded as well. If you do need to go, I want to say again, thank you for joining us. And feel free to get on the dashboard in a few days and watch this presentation and skip to the end and get to those questions if you aren't able to stay on. So let's get to some of these questions. Has the FERC or any other regulatory bodies really accepted the use of GeoWeb systems on dam embankments? So that is on a bit more of a case-by-case basis. It is not universally accepted by FERC, but it has been accepted by a number of state regulatory agencies for use on both the upstream and downstream side of dams and earthen dikes. It's also been accepted by a number of, like state DOTs or other regulatory bodies in terms of, not being necessarily on a dam, but for containment. One project that comes to mind was in New York State. The GeoWeb system was placed over an earthen dike to contain a potential liquid natural gas spill. And so it was accepted by a number of regulatory agencies in New York State for that type of application, which would be similar. So if you do have questions about a specific agency, or if you're in a specific state and you have those regulations, we are happy to direct you to any resources that we have already sort of gotten on our own and shown that it's worked, or direct you to people that can help you get those acceptance from regulatory bodies. So great question. A number of questions about maintenance of the GeoWeb system on slopes. Sort of specifically, it seems like in terms of the grass or the vegetated channels. So yes, you can mow over those. Like I said, your standard lawn mowing equipment is going to be fine, or you can choose to have, flowering vegetation or some of those like tall grasses that don't necessarily need to be mowed, and just sort of let that type of vegetation grow and flourish on your slope. And then, that's going to cover the GeoWeb panels. It's all going to be, something that works with the system to help hold it all in place. So that's sort of a question of the aesthetic that you're going for, whether you want the mowed lawn or if you want sort of the more wild grasses sort of thing. But there's really no special lawn maintenance requirements, no special lawn mowers or anything like that. In terms of aggregate, if you use that as your infill material, as long as you choose the size stone that we recommend to fit within the panel so that it doesn't get washed out, you're not going to need to do continual refilling of the stone. The stone's just going to be there in place. And then concrete is obviously just concrete, not a lot of maintenance required there. So good question. Very, very minimal maintenance requirements for whatever you choose. So some questions about how the GeoWeb system compares to articulated concrete block mats. So it does sort of get into some specifics there about what exact mats you're using, how thick the concrete blocks are, that sort of thing. But in general, they're comparable or even better to use the GeoWeb system in terms of the allowable velocities and shear stresses, especially if you use concrete-filled GeoWeb. That allows you to have that really thin concrete cross-section and allows for incredibly high flow velocities over the top. Usually a bit higher than what an articulated concrete block mat could handle, because you're not going to have those gaps between the blocks like you would with ACBs. A GeoWeb, concrete-filled GeoWeb is going to be a smooth surface, which would allow for higher flows. If you were to do a topsoil or a stone infill, might be slightly lower allowable velocities. It does depend on the ACB mat as to what that is. So, yeah, some considerations there, but we're happy to discuss those with you if you do have a specific project in mind. Let's see, some other questions. Some questions about the actual concrete within the GeoWeb cells. So there's no specific like concrete slump or air entrainment or even aggregate to fines mix. So sometimes you do have regulatory bodies that tell you what the concrete mix needs to be, and whatever that is usually sufficient. Really any sort of concrete that is going to be roadworthy is going to be sufficient to be within the GeoWeb panels. In general, you can use higher slump, lower strength concrete when you have it in or on slopes where you don't expect vehicle traffic, because you don't need the high strength concrete to support the vehicle loads. You really just are trying to create that smooth surface that the water is going to flow over. So you can do those higher slump, lower strength concretes. And really high slump allows easier installation. It helps you sort of rake that concrete down from the crest into the cells. So that's something to consider as well. Some great questions here. Looks like we have time for one more. So does this system require a certified installer? So that's a good thing, a good question, especially working on things like dams and levees. Sometimes there's extra requirements of who can work on those sites. And so I can say that there's no like certified like GeoWeb only installer that's necessary. Your standard construction crews, anybody who's already allowed to work on one of these structures, can be the contractors, the workers that you use to install the GeoWeb panels. So it's a very easy system to learn in terms of installation. We have some manuals, we have video guides on our website, all of that good stuff to help teach people how to do it. We also will allow or have someone who is able to come out to your project site, either directly from Presto or from one of our qualified representatives in a state or a local area to you, who could come out on site, do a day or so of training, watch the first bit of installation, make sure that everybody is feeling confident in how it all works, so that you can do the installation on your own. That way you don't need to worry about getting somebody new out to your site that you've never worked with, getting them permits, that sort of thing. So it is basically your own crew with a representative from Presto Geosystems on site who can work with you. Okay, so this has been a great session. If there are any questions I didn't get to, please feel free to either email me directly or go through our contact page on our website. Feel free to check out our website. We have lots of good videos, case studies, pictures, lots of documents that you can use to see if this is going to be a good application for you. If you do have a specific project, feel free to reach out. We're always happy to discuss things with you, even, very high level, very early in the design process, just, hey, is this going to work? Always happy to talk about it. So I hope you all have a good day, and we will see you in the future for more webinars or to talk about some project details. Okay, bye.